So far, we've talked about two techniques for factoring. We've talked about factoring out GCFs, that was our first method, and then we've talked about factoring trinomials. That word tri just means it's something with three parts. Like tricycle has three wheels. Specifically, we talked about factoring trinomials that look like x squared with no number in front of it plus a number times x plus a constant term. We'll talk later in the semester about what do you do if there's a number in front of the x squared. For now, this is all we need. But there is one more factoring technique that we need, and that is something called factoring difference of squares. Difference of squares are things that look like a square minus a square. So that word difference just means subtraction. So difference of squares means subtraction of two squared things. And as usual, since factoring is the opposite of multiplication, I'm going to lead into this by looking at an example multiplication problem. So suppose we need to multiply x plus 2 times x minus 2. Foiling that out, I'll have x squared, and then I'll have minus 2x, then I'll have plus 2x, and last I'll have 2 times negative 2, which is negative 4. Now the interesting thing with this multiplication is that those x terms cancel each other out and just go away and leave us x squared minus 4. Now, suppose we're asked to factor x squared minus 4. That means we're supposed to come up with a multiplication problem that you would do to get x squared minus 4. Because we've just done the multiplication, I know that x squared minus 4 is the answer to x plus 2x minus 2. But how would I know that if I hadn't just done the multiplication? I wouldn't. This would be really hard to come up with. Well, there's a formula called the difference of squares formula that says if you want to factor something squared minus something squared, what you're going to get is the first thing that was being squared minus the second thing, in parentheses, and then times the first thing that was being squared plus the second thing that was being squared, also in parentheses. And by the way, this can be used as a very handy multiplication formula as well, working that direction. So what I would usually do for this first example, I wouldn't FOIL it out and then cancel the middle terms because I have that formula memorized, and I know if I do something plus something and then the same two somethings with a minus in the middle, I know I'm going to get the square of the first thing minus the square of the second thing. Anyway, it's more important for factoring though, because for factoring it's not a shortcut for some other method. It's the only way to do it. Now, to use this though, I have to identify what a and b are. In other words, what is the base on each squaring? I can't have a number sitting out in front of the x squared. I have to have just a single thing being squared. Well, 4x squared is the same thing as the square of 2x, right? Because if I square 2x, remember our rules for exponents say if you're multiplying inside parentheses, each thing in the parentheses gets the exponent. So yeah, that's going to be 4x squared, just another way to write it. Then I have the minus sign, and 25 is the square of 5. So I can identify that the first thing being squared, which is the a in the formula, is 2x, and the second thing that's being squared, which is the b in the formula, that is the number 5. So I know this is going to factor as a minus b times a plus b, because it's an a squared minus b squared kind of setup, where my a is 2x and my b is 5. So I'm going to have 2x minus 5 times 2x plus 5. And as always, you can FOIL this out to check your answer. Let's try factoring 36a minus ab squared. 36 is a perfect square. That's going to be 6 squared, so that looks good. But the a is not a perfect square, so that's in the way. Remember, in that first place, I have to have just a single thing being squared. That's why up here I had to write that 4x squared as the square of 2x. I have to have one thing being squared. I can't have something times something being squared. So a times 6 squared here is not a good situation. But notice there's an a in the second term also. And remember I said, let's actually go up to it because I don't know if we underlined it. Right above where we started factoring trinomials, it says important. Always begin any factoring problem by first factoring out the GCF, if there is one. Because sometimes if you don't do that, you can't do the factorization at all. Sometimes it just makes it harder, but in a case like this, we can't do our factoring at all if we don't factor out that GCF. So let's bring that out front. Now, in the parentheses, we have a perfect difference of squares. I've got something squared minus something else squared. So that's going to factor as 6 minus b times 6 plus b. Okay, I have one more example of difference of squares for you. I don't know if it's obvious that this is a difference of squares, but by the way, anytime you need to factor something that's two terms with a minus in between them, ask yourself if this is maybe a difference of squares, because these come up a lot. A lot. Okay, the 36, that's not bad. That's just a 6 squared. What about the x to the 4th? Could I write that as something being squared? Well, remember our rules for exponents that say if you have something raised to a power and then to a power again, you multiply the powers. So, what if I want this to come out to be x to the 4th because that's what's in my expression. What if I had an x squared in there? Yeah, that would work because this would give me x to the 2 times 2, which is certainly x to the 4th. So I can put an x squared in the parentheses there. So that means that in this problem, the role of a in the formula, so a is the first thing being squared, the role of a is being played by x squared, and b is the second thing being squared, so that's being played by a 6 in this problem. So where I have a minus b, I'm going to put in x squared minus 6, and then the part of the formula that says to put in a plus b, for that I'm going to have x squared plus 6. That's it for the basics of factoring. We will do more, less basic factoring later, but this is it for now. Good luck with the homework. As always, reach out for help if you have questions.